Here we have a SAT math problem. Okay, let's go to the question. Y equals to ax plus to b, 5x negative 3y equals to a. Here we have a system of two linear equations. In the system of equations above, a and b are constants. If the system has infinitely many solutions, what is the value of b? Okay, before we start solving this problem, let's consider a concept. That is, let me consider a system of two linear equations in standard form. That is, a1x positive b1y equals to c1. And let me consider another linear equation in standard form, that is a2x positive b2y equals to c2. Okay, here we have system of two linear equations in standard form. Standard form means we have the x term and y term on one side of the equation, the constant on the other side of the equation. Okay, if this system has infinitely many solutions, then the ratio of the coefficients of x, the ratio of the coefficients of y, and the ratio of the constant terms must be equal. Okay, now let me write the ratio of the coefficients of x, that is a1 over a2, and the ratio of the coefficients of y, b1 over b2, and the ratio of the constant term, that is c1 over c2. Since the system has infinitely many solutions, all these three ratios must be equal. Okay, now let's apply the same logic in our problem. So for that, we need both the equations in standard form. The second one is already in standard form. That is, we have x term and y term on the left side of the equation and constant on the right side of the equation. But here in the first one, we have only y term on the left side, x term is on the right side. So we have to get rid of this x term and get this x term on the left side of the equation. Okay, now let me take the first equation over here, that is y equals to ax positive b. Let me subtract ax from both sides. When I do so, this positive x, negative x will cancel out. Then I'm getting negative ax positive y equals to b. Okay, the second equation is already in standard form. We can write this one as it is. That is 5x negative 3y equals to a. Okay, now let me write the ratio of the coefficients of x, that is negative a over 5. And also the ratio of the coefficients of y is 1 over negative 3. And the ratio of the constant terms is b over a. Since the given system has infinitely many solutions, all these three ratios must be equal in value. That is equals to. Okay, our aim is to get the value of b. So for that, what we have to do is we can equate the first ratio and second ratio, and when I do so, I'll be able to get the value of a. Once I get the value of a, I can equate the second one and third one, and I can get the value of b in terms of a. Then I can plug in the value of a and find the value of b. Okay, now let me equate the first ratio and second ratio, that is negative a over 5 equals to this 1 over negative 3 can be written as a negative 1/3. Okay, so here we can multiply both sides of this equation by negative 5. Let me do it. Okay, when I do so, this 5 will cancel. That is 5 goes into 5 one times. When I multiply this negative 1 and negative a, I am getting positive a. Okay, here when I multiply this negative and negative, it will become positive. 1 times 5 is 5, that is 5 over 3. Okay, here I got the value of a, that is 5 over 3. As I said earlier, now we can equate the second ratio and third ratio. We can get the value of b in terms of a. Okay, now let me equate the second one and the third one. Then I'm getting, this 1 over negative 3 can be written as 1 over negative 3 equals to b over a. Now let's multiply both sides of this equation by a. When I do so, this a will cancel. A times negative 1/3 can be written as negative 1/3 a equals to b. Okay, here almost I got the value of b. That is, I got the value of b in terms of a. Okay, so to get the exact value of b, we have to plug in the value of a. That is this 5 over 3 for a over here. Then I'm getting negative 1/3 times 5 over 3 equals to b. Negative 1 times 5 is negative 5, and 3 times 3 is 9 equals to b. Okay, here I got the value of b, that is negative 5 over 9. We find this negative 5 over 9 in answer choice C. The correct answer choice for this question is C.